Equal. Now let's use what we learned yesterday, the concept of substitution. If you want to find the other variable in either of the two rows, does not matter which one, we now know y. Put it in the spot where y is. So I'll take the top row. 2x plus 3 times 3 equals 5. Either row should work because this is going to make both true. Can you solve for x, please? I got -2. Okay, so as an ordered pair, that's -2, 3. If I ask for the value of x minus y, that would be -2 minus 3. The answer to that would be -5. Nope. Nope. Anything goes. One, both, none.
So you can't.
You can.
Oh, okay.
I thought you said
no.
Well, in this case I can't because that wouldn't work. Right. But in general, you mean when you're solving? Yes. You might not. You might only need to do one of them. Yeah. We are. Yeah, because this is still Unit 7 in our book. It just so happens there's a lot of SAT stuff on it, so that's why I'm spending more time.
Where'd you get the negative
You do, then you minus 2 from the x.
I skipped Unit 6.
Oh,
Remember I talked about it yesterday? Yeah, but even so, 6 and 7 really are. We go from kind of trig for 3 chapters, because trig, and then vectors have some SOHCAHTOA stuff in it. So they have a little bit of trig in it, and then we go to lines and systems. So. Okay. Linear systems. Let me tell you what they look like. If there's 3 possible cases for linear systems. Either they have intersecting lines. Think of slope-intercept form. Slope-intercept form. What would be true about the slopes if we had intersecting lines? They don't have to be positive and negative. They don't have to be reciprocals. That makes them perpendicular. They just have to be different. So if I don't give you a picture of a graph and I ask you how many solutions something has, it would be beneficial to at least figure out the slopes of the lines. Because if lines are sloped differently, at some point they're going to meet. Okay? So this would be one solution. I'm going to write here different slopes. And by the way, their y-intercepts could be the same because that's where they meet, or they could be different. We don't know. I'm not going to address it because it doesn't matter. What about no solution? Okay, so no solution looks like parallel lines, and you're right, those would have the same slope, but they have to have different y-intercepts. When you're solving them in an elimination situation, what happens is you get an untrue statement. Like you get 0 equal. Basically your A's and your B's are the same, the X's and the Y's are the same, but the other side's not the same. That's kind of like your y-intercept. The last one, infinite solutions. What happens? Oh, I just love algebra. I draw it like that. I draw a line on top of a line, but really it's just the same line. Sometimes I call it a coincident line. That's an infinite solution situation. Infinite solution. The lines are exactly the same. Everything's the same about them. So same slope, same y-intercept. Do you guys remember learning about that in algebra? Kinda, sorta?
Yes.
Okay. Let me go through. These are actually off of an SAT. Because these look like systems, but they're specifically asking this question, and they're not hard questions. but they trip people up. So that's why I wanted to talk about. So it says up here, in the system of equations above, A and B are constants. That just means they're numbers. If the system has infinitely many solutions, what's the value of A over B? Here's the deal. Let's figure out what A and B have to be. That's all we're going to do here. And then we're going to do A divided by B. If they're infinitely many solutions, they have to be exactly the same line. And actually, I learned something new this year. Mrs. McDonald taught me a cool little trick. What she showed us is that in Algebra 1, if they're the same line, the ratios of the coefficients have to all be the same. And what I mean by that is A over 2 has to be equal to B over 8, and that has to equal 12 over 60. So what's in front of here and here, those all have to be the same. Because the system isn't multiplied by the same thing right now. Is that making sense? They don't look like the same line. I have to figure out what those numbers would be. Okay, so you can use any of these proportions, or you can even do this. Isn't 12 times 5 60? So if you wanted to figure out what these were, then we would just solve the equation, right? 5 times A equals 2, or 5 times B equals 8. Or if you're like me and you like to cross multiply, just pick one and cross multiply. So 60 times B equals 8 times 12. Can you guys solve for B, please? I got 1.6. Did you get the same thing? Yeah. Cool. All right, let's do the same thing with A. Same idea with A. I'm going to do A over 2 equals 12 over 60, and I'm going to cross multiply and solve. Or if you want to just divide them by 5, 2 divided by 5 and 8 divided by 5, that's fine too. So I get 60A equals 24. Okay, what's the ratio of A to B then? 1/4 or 0.25. Okay. What are some other things you notice? What's another way you can do this? What do you think? Give me some, like, what makes sense to you kinds of things.
Multiply the top out of the 2 or the 8.
Yeah, now just be careful of that because we're not going to do opposites, okay? Multiply the top by I'm going to multiply by a 5 to get, the reason why I'm doing that is because I know that the lines are the same, and you see how that's a 60. And then you could just say, oh, 5 times B has to be 8, and 5 times A has to be 2, so you can do it that way. Okay, there's different ways to do it. What if there's no solution? If there's no solution, I have to give you one of the A or the B, because the y-intercepts, which would end up being over here, would be different. Well, I'll show you some more of those. Oh, I have a little handout. And we'll do some of that. How many solutions does that have? Okay, what if I just give it to you and I want you to figure it out? Remember how I was saying you should figure out the slope and the y-intercepts? Okay, let's figure it out. Be careful on this, because this isn't slope-intercept form. I'd have to move it to the other side. So this becomes y equals negative 3x plus 2. Agreed? Okay, let's do this guy. I have 2y equals, I'm going to move that negative, or that 6x to the other side. Now what do? Divide by 2 everything. Okay. How many solutions does this have? No solutions. Why? They have the same slope, different y-intercept.